Hi there, I'm Gus, and I've come to talk about mathematics, or more precisely, about the teaching of maths. That's what I've done through most of my working life. I've taught learners of all ages, from preschoolers right through all levels of primary and secondary schooling, and adults, especially teachers and those training to be teachers. And I've taught people who had a wide range of ability at maths, from those who were having difficulty and needed help, through to those who had special ability and needed some extension. And I'm also the creator of beans, which are a teaching resource in mathematics used in schools throughout the country. Now, I want to talk about what I've learned from all those years of experience. For quite some time now, as I'm sure you're aware, concern has been expressed about the standard of achievement of our students in mathematics. It's a concern that I share. We're not doing as well as we could and should be doing. And I think that there are very definite, identifiable reasons for this state of affairs. And I want to have a look at what those reasons are. And more importantly, I want to show how we could be doing it better, to give a bit of a blueprint, if you like, for the teaching of mathematics. Why would you be interested in that? Well, you might want to teach this material, either as a classroom teacher or as a parent or grandparent who wants to help your own kids. If that's the case, then you are the first and foremost audience that I have in mind. I'm going to explain the mathematical ideas involved, and I'm going to show you how to get those across to learners. What to do, what to say, what equipment you need, and how to see what a learner has understood or not. Or maybe you just want to understand some things that haven't made sense to you in the past. Perhaps you're a casualty of our schooling system, and you came out of it thinking that maths is an impossible subject, and that you're hopeless at it. Well, it isn't. Maths is really quite straightforward when it's explained. And you most certainly are not hopeless. And if you'd like to give me a bit of your time, I'll show you that you can do maths. You might even still be at school. Perhaps you can do maths quite easily. But you get bored because what you do in class doesn't make you think. I'd love it if you'd stay around. Because as well as making the basics accessible to everybody, I've got a special personal interest in extending our best and brightest minds. And I'll give you something that will make you think. So that's what this is going to be about. I'd just like to point out that this is not a low budget production, it's a no budget production. I'm doing this at home in my own living room. And it may not be quite as polished as a professional presenter, so I'll ask you to put up with any little glitches or stumbles that occur, as they do whenever you're having a real-time conversation. Polished presentation is nice if you can have it, but quality of the material, I'm sure you'll agree, is a much more important thing. And I hope you'll find this to be of good quality. Okay, let's get started. Where am I going to start? Well, not in the usual way that we start with kids, by learning to count. I want to look at the symbols that we use to record stories in our language. You're probably sitting in front of a keyboard right now, and on the keys there you've got symbols or characters. If you tap away on those, you can make things appear on the screen. Those fellas. I've scrambled them up. But there are three groups in there. First of all, there's this group. Now, some questions. They're all characters or symbols, but we've got a special name for these ones. What do we call them? They are... And if I said, can you unscramble those? Put them in the conventional order that we have for them. What are the first three and the last three? And when you've written them out like that, what name would you give to that string written out in that order? And finally, we use them singly and in groups to write things like this. What do you call those? Okay? Well, I think I know what you've said. You will have said those are letters, and they go A, B, C through to X, Y, Z. And that string is called the alphabet. And we use them to write words. Is that what you said? That it is. Now let's look at the second set. These fellas. Same questions. What are you going to call those characters? And if you wrote them out in a conventional order, unscramble them, what would be the first and last? And when you've got that string written out, what are you going to call it? This time, I'm not so confident about knowing what you will have said, because you won't all have said the same thing. Pretty sure just about everybody will have said the same thing there, but not here. Straight away, what are you going to call those? Most of you probably have said numbers, but that's not the only thing you might have said. You could have said numerals, or digits, or figures, because we don't have a universally accepted term for these. And when I said, write them out in order, I know what you will have done with the majority of them. You will have put 1 to 9 in that order, I'm sure. What about this fellow? I do know that you won't all have put that in the same place. Some people want to put it down here after the 9. And some people will put it down here before the 1. Numbers, well, probably more people put it after the 9 from my experience than put it before the 1. But it's not a wholehearted thing. There's quite a considerable minority will put it there. And what are you going to call that string, wherever you put the 0? Well, you're searching for a term parallel to alphabet, and we don't have one. It's a bit of a trick question, really. So what you probably said was just the same thing as you said for the first question. If you called them numbers, you probably just said they're the numbers. Why don't we have a term? Because we don't actually teach the string as such. We teach children to say their letters, their alphabet, but we don't teach them to say that string. Instead, we teach them to count, and we're going to be looking at that. Finally, what do you call those? Well, the vast bulk of you will have said numbers for that, but you may have said numerals or figures. You won't have said digits, but you may have said figures. So here's the first thing that can be a problem. We don't have an agreed language when we're talking about these symbols and the things we write with them. And that's the first thing I want to sort out. When I was a boy, yeah, I know, it was a while ago, the word numbers would have been the thing we would have used for all of those questions. The only time we would have used the word digits would be to distinguish how many of them we had in there. We would have said, that's a 3-digit number. Or we could have said figures there too, particularly if it was a monetary amount. For some reason we talk about a 3-digit number, but a 5-figure salary. Figures could also be used just to mean numerical data, as in, have you got the figures for that? The word numerals was never used except in one circumstance, and that was to distinguish between these and other systems for writing numbers. For example, the Roman numerals, the familiar I, V, X, L, C, D, M that they used. They took letters of their alphabet for a double purpose, gave them numerical values as well. So did the Greeks. Many other cultures, like hieroglyphics, had special symbols for numerical ideas. All symbols which are used to record numerical ideas are numerals, and there are a great many of them. Our particular set come from around the 9th century, from Indian and Arabic regions. Hence, mathematicians call them the Hindu-Arabic numerals. They've been described as the most successful intellectual invention of all time, because basically they have pushed all other systems out of the way. We have thousands of languages and a whole multitude of alphabets to write those languages, but we have essentially one system for recording numerical ideas, and that's those symbols there. So that was what we did in my youth. They were numbers. Then an event happened that changed the whole course of mathematical education history. A major change, a sea change it could be called, except that it didn't happen in the sea. It actually happened up there in space. And what was that? The Russians got up there before the Americans. Sputnik's 1, Apollo's 0. And Uncle Sam was not a happy chappy. And he decided that something needed to be done about his education programs in science, particularly physics and in maths. And so they created a new program that came to be called New Math, or New Maths we call it here. Well, who created this program? Americans, obviously, but I mean, what background did they have? The background of the writers of this program was in mathematics, not in teaching. They knew diddly squat about teaching children. They weren't the best mathematicians either. In fact, the best mathematicians were busy being mathematicians. These were people who weren't getting very far in their career, so they took this on. They'd studied mathematics through to PhD level. And basically what they did was to take the place that they had reached at the end of this long study of mathematics and try to make that the starting point for teaching children. There was a total emphasis on set theory, with all its rigour and formal jargon and notation. And they spoke in that language. This was coming in as I started teaching, and I found myself teaching children this sort of thing. Which would be read as, for all AB, A plus B equals B plus A. That's the commutative law of addition. Is it important? Well, yes, it is actually. The idea behind it is, but the notation is not important. In fact, it only serves to get in the way of understanding. What it's saying is that whenever you take two numbers that you want to add, it doesn't matter which one you put into the calculator first. You can put that in and then add that on, or you can put that in and then add that on. And it is an important idea, because in some things it does matter. Subtraction, it matters which order you put them in. So, important ideas got lost in this terribly technical jargon and notation. Let's get rid of it. As part of that jargon, they introduced the term numerals in a new and different way. They wanted to distinguish between the idea of how many things there are and the label that we put on that idea. The how many things, how numerous they are, or the numerosity if you want a technical term for it. Numerosity is just a word that means how many there are. And we're going to put a label on it. There, for example, the label we put on is that. So you've got the idea of how many things, and you've got this label which they call a numeral. A numeral is a name for a number. A numeral is what you write, but a number is what you're writing about. And it's a fine philosophical nicety, not just too fine for children, but obscure to their teachers. And it wasn't long before all this technical jargon and the impact that it had on kids not learning maths showed up. The American mathematical establishment rose up against it and decried the program completely. They found a spokesman in Professor Morris Klein, a noted American mathematician and writer about mathematics. And he wrote a book, this book, Why Johnny Can't Add, The Failure of the New Maths. And he tells the story of a writing group that started a chapter, Writing Large Numbers, until it was pointed out, you don't write numbers. Oh, writing large numerals. You mean, no. Writing numerals for large numbers. And Klein gives us as an example of the absurd nonsense you get into when you try to be highly technical. He has this very cutting and inciseful commentary to make about the program. The new mathematics as a whole is a presentation from the point of view of the shallow mathematician, who can appreciate only petty deductive details and minor pedantic sterile distinctions, such as between number and numeral, and who seeks to enhance trivia with imposing sounding terminology and symbolism. And it is right on the button. He also adds, the real problem with language is not precise language, it is clear language. What we need to do is to talk to people in simple words that they understand. Now, this program was received differently throughout the world. Some countries avoided it like the plague. The Netherlands was one, and they consequently became world leaders in mathematical education thinking. Other countries, and unfortunately New Zealand numbered among them, jumped right on board this bandwagon. And our educational bureaucracy oversaw the production of a new set of textbooks. This series, School Mathematics. This is the first of them, Book 1A. And we find that right from the very beginning, here we are, page 2, we are telling children 1, 2, 3, 4 or 5 are names for numbers. They are called numerals. A numeral is a name for a number. And no longer do we say simple things to a 5-year-old like, how many buttons are there? We say, name the number of buttons. Well, it had the same effect here as it did in America, of getting in the way of children's learning. I shall be recalling this to the witness stand to answer for some of its other sins at a later stage. It wreaked its havoc, came in with a fanfare of trumpets and slunk out the back door. And a new program came in, called Beginning School Mathematics, BSM. Now it's readily seen when you look at this program that it's a bit of a potluck dinner. And many people have contributed to it, and every author used whatever terms they liked. There's been no getting together and sitting down and coming up with an agreed set of terms. You'll find the symbols referred to by all of these names, numbers, numerals, digits, figures, even digit labels, one person called them. Another problem with the program was the very rigid, structured way it told teachers that they should follow through with it. As a report into it showed, this simply served to hold many, many children back. So, exit BSM. And that brings us to the present day. Where are we at currently? This is what we're currently using, the Number Project. It's been around for a while now. I came across a newspaper extract I'd saved the other day where New Zealand Initiative are railing against it and wanting to return to learning the basics by rote learning methods. And I see from that this has been around since 2001 and that about $70 million have been spent so far. That was 2 years ago. That's a lot of money. And we would hope to get some pretty good results for that. And I think it's certainly fair to look at it and say, how well are we doing? Is this good material? Because two things we need to understand. Firstly, the material which Party Central, the ministry, provides for teachers to use, the curriculum materials, will have a very important effect on how well our children learn. Yes, teacher knowledge and quality are important, no doubt about that. But the material that you give them, what you want them to teach, and how you want them to teach it, is very clearly important. And it's perfectly reasonable to ask, because the second thing is, not all material is particularly good. We've only got to look back into the past and look at this to see that it is perfectly possible for educational authority to provide things that are not good. We're going to be looking at this in quite some depth. The first thing today is to look at its use of language. We don't have to go far to see what happened to this term numerals. Back in the past, we tried to make this pedantic, sterile distinction, as Klein called it, between numbers and numerals. A numeral was what you wrote, a number was what you were writing about. Now the two terms are used as if they are completely interchangeable. And we can talk about the numerals to 100 and then call them 1 and 2 digit numbers. What is actually achieved by having this extra term, numerals? Nobody uses it. Mathematicians don't use it. Every man and woman in everyday life call these things numbers, as mathematicians do. What do we gain by having an extra word in there? Absolutely nothing. Why not just call them numbers? Well, I'm going to resolve this issue for one and for all as far as I'm concerned. I'm going to have two words that I use. Digits and numbers. And just as I say, that is a word made up of 3 letters. That is a number made up of 3 digits. We have digits which we use to write numbers. Question solved. Now to a much, much more important question. The $6,400 question, really, because if you get this wrong, it's going to have a profound effect on children's learning of mathematics. And that is the question of, where does the 0 go? Does it belong at the end of the line after 9, or does it belong at the beginning of the line before 1? Now, if you ask people, as I have done, who put the 0 after the 9, why does it go there? They give two reasons. One of those is this fella. Well, that's the way I've always seen it written. Look, there it is on the keyboard. Yeah, well, it is. But hey, that's not the only way it gets arranged on keyboards. Here's another arrangement on the same keyboard. And there's yet another arrangement on some keyboards. And that's that one. That's the arrangement on your calculator. But that's the arrangement on your telephone, on your remote control, on an ATM machine. The keyboard isn't an authority on this. It's just the way things happened. Any more than it's an authority on the alphabet. What happens on the keyboard doesn't tell you the order of the letters in the alphabet. The other reason people will give is, well, counting starts at 1, doesn't it? We've all learned to say 1, 2, 3, 4, 5. Well, that's true. We have all learned to say that. And we're going to have a look at this further down the line and a serious talk about counting when we start learning to count. But in the meantime, we're not talking about the process of counting. What we wanted to look at is what order do numbers occur in. And I'm going to suggest to you two voices to listen to when you have a question to ask like this. And those voices are, first of all, the voice of the expert. In this case, a mathematician who has studied the subject in some depth. Secondly, the voice of your plain common sense. Got to be a bit careful about that plain common sense, because sometimes things aren't quite as simple as they might sound. Got to be a bit careful with the experts too, because sometimes people who are regarded as experts by others or by themselves may not be quite as expert as we would like them to be. This was written by experts. So, let's listen to these two voices. Firstly, let's start with plain common sense. What are we going to do with these? Well, we're going to use them to tell the story about how many things there are. Take the one from here. 3 is the digit that we use to make a number to tell us how many things there are in there. If I change that, put another one in there, what do? We put it back and take the next one going to the right. If we take something out, we go one to the left. Take out another one, go one to the left. Down to 1 now. And if we take that out, can we tell the story of how many we've got in there now? Best we can. There it is. That's the role that 0 has in the system. It's the answer to the question, how many are there when there aren't any? So clearly, its logical place is before 1. It doesn't come after 9. 10 comes after 9. But that's not 0. So, plain, simple common sense says the 0 comes before the 1. What about the voice of the mathematician? Well, if you ask a mathematician, where does the 0 come? He would probably tell you, yes, an Italian mathematician by the name of Piano answered that question. Mathematicians have a process. First of all, they use their ideas intuitively. Then, somewhere down the line, they formalise them. They define the terms that they're going to use, and they give a set of axioms, they call them, which are basically statements that say, this is what we're going to take for granted about this subject in hand. Now, Peano did this for number, around 1890, and he formulated a set of 5 statements, the Peano axioms, they're called. You can find them on the net if you like. But I'm going to give them to you in a pre-digested form, because I promised you plain, simple language, so we'll get away from the mathematical formality. What Peano said was this. Number. Well, number, we're talking about how many things there are. That starts at 0 and goes in steps of 1 in an unbroken, never-ending single file. There's no branchings in or branching out. Every number has a place in this string, in this line, in this queue, if you like. And there will be the next one in the queue, the one that comes after it, and there will be the one that came before it in the queue, except for 0. And that doesn't have a one that comes before it, because 0 is at the head of the queue. That was Peano's answer. That is the mathematician's answer. And it agrees with our common sense. 0 is the beginning of the queue of number. And the implications are enormous if we don't teach children this from the very beginning, as you will see as we go on. Interesting thing though. That was Peano's second attempt. When he first wrote his axioms, he had numbers starting at 1, not at 0, which just goes to show that this insidious process that we have of saying 1, 2, 3, 4 has got into our heads that number starts at 1. It doesn't. And he corrected himself. But 130 years later, this still has not got through to people to whom it should have got through. For example, the ministry has a website that goes hand in hand with this material. And if you look on that website, under the heading Teaching Numeracy, there is this bold, colourful sign. Actually, I think it might have gone. It was certainly there for a decade, and I have downloaded that from there. But last time I looked, the sign wasn't there. It hadn't been replaced. And I don't imagine that they are going to replace it with a sign that starts at 0, because to do so would be tantamount to saying, we got that wrong, didn't we? And I don't think that that is going to happen. But they have got it wrong, and even if they've taken the sign down, it hasn't altered the fact that the thinking that goes on in this program does not have firmly in mind the idea that number starts at 0. Right, well I'm going to stop here, but let's just recap at what we've seen. May not seem like very much, but it's very important material. We've begun by getting our terms right, or settled. We have digits which we're going to use to write numbers, and those digits go from 0 to 9 in that order. Next time we're going to look at beginning teaching this to children. Hope to see you again. Ka kite.